Hello, everyone. Welcome to another of Trail of Bits streaming series about fuzzing and Echidna. This time we'll be talking about fuzzing with reusable properties and how to use our new repo critic properties. Uh, I'm Guillermo Larregay. I work as a security engineer one at Trail of Bits. You can follow the rest of the blockchain team on Twitter. You can get updates on what they are doing. And who are we as a company? Okay, Trail of Bits is a company that helps developers to build safer software. We are focused on R&D. We use the latest program analysis techniques, and we also have developed some of the used, most used software in the blockchain space, such as Slither, Echidna, Tiller, Amarna, and Solcy Select, and a few others. So, what's the agenda for today? We will be talking about what will you get as a developer from this tool, from this repo that we are releasing. We will be seeing how to go from specification to test suite in and create new properties for your own contracts to create your own tests. We will be talking a bit about our motivation for this tool, what uh, what the reasons are behind this tool. We will be also talking about a bit about fuzzing, uh, how to what fuzzing is and how to fuzz using Echidna and its workflow. And then we will go deep into the properties repo. We will be talking specifically about ERC20 tests. Uh, there will be another stream with the rest of the tests next week. We will see a hands-on example on how to test ERC20 tokens, and at the end we will have a small bonus about HEVM cheat codes and how to use them in Echidna. We will be also be sharing with you some fuzzing tips in general and how to create new invariants so you can collaborate with this repo. So let's start. What will I get from this tool? I mean, what will you get as a developer from this tool? Uh, our idea was to summarize these three key points. The first of which is identify and write your contract properties. So, given that you have a contract you want to test, you should be able to identify and write the properties to use a fuzzer with this contract. The idea is that we will go through the steps to help you identify and write your own properties. Then we will show you how to test your contracts with Echidna, with the fuzzer, the, the one that we developed, and try to help you answer the questions if your tests are any good. So we will be sharing with you some tips on how to see if your tests are valid, if all of your code is tested, and where might be some spots that were missed by the fuzzer. And the last one is uh, that we want to share with you that we want you to use fuzzing tests as a complement to static tests. Usually, developers are used to static tests, and they are they have their own tests already created. And one question that usually comes up is, will I have to change all my testing suite with fuzzing test? No. The idea is that you use the fuzzing test as a complement. So the more you test a contract, the more secure it should be. Let's go on how to go from specification to the test suite. In this particular case, we will be talking about Ethereum standards that most of you know that they are defined in EIPs and ERC, for example, ERC20. Um, and these standards define the expected behavior of the contracts in a way that's not ambiguous. So the developer or the person implementing the standard is completely sure about what the functionality should do and shouldn't do. They use a very specific language that is defined in Internet Engineering Task Force requests for comments 2119 and 8174. We won't go deep into this, but they use specific words with a well-defined meaning, such as must, should, recommends, and so on. And the idea is that when you implement a contract to be standard compliant, you should take into account the specific meaning of these keywords. For example, let's see the ERC20 transfer function. There is an excerpt of the definition in the ERC specification here, and it says that the transfer of zero values must be treated as normal transfers and fire the transfer event. This keyword must is capitalized because of the RFC that we mentioned a bit ago. So what's the idea? If you want to test that your transfer function is compliant to the standard, you should make sure that this property holds in your contract. Your token should be handling transfer of zero value the same way as a normal transfer with value and fire the transfer event. So the idea of this part is that we will explain a bit how to go from specification to test suite. First of all, we will be talking about unit testing, that it's what most developers are familiar with. So you have the specification and you create a test, a unit test that makes sure that the specification is compliant. In this case, we have a hard hat test that implements the transfer of zero value test. And in this particular case, we are only testing that the transfer from the contract address to the user one addresses is okay, it's not reverted, and the balances aren't changed. The next step is to test with fuzzing tests or property testing from a specification. In this case, we don't just test with one single instance of, for example, the recipient. In the previous case, we only tested with user one. In this case, we create a function that can be parameterized, and you can choose which address will be the recipient of the tokens. So this makes a more general test in the sense that this parameter can change value, and you can make more thorough tests that can change different parameters. In this case, we are only changing the destination address, but your test can fuzz or change the value of a parameter and test in more cases. We created a lot of these properties from the specification, in this case for ERC20, but the idea is that you could also create your own ones by knowing the invariants in your contracts or the specific properties of your contracts. This particular piece of code is part of one of the properties that are implemented in our repo. Let's talk a bit about what motivated us to do and release this repo with properties. We wanted to provide a reusable, out-of-the-box solution for developers to test their standard compliant code with Echidna. We know that fuzzing tests are not so popular, and we wanted to make sure that fuzzing tests become the norm in testing smart contracts. We also wanted to make it ready to use, so you can integrate it with an existing project without friction. So you just add the properties repo and you can start testing the properties in your code. It was meant to be extensible, so anyone can create more properties. You can add properties at will. And last but not least, it must be efficient. So developers spend less time building tests and more time developing, creating new code. So This has another side effect, interesting side effect, is that if you integrate these tests with your own code, you increase the baseline for future audits, so that the auditors will not be wasting their time on low-hanging fruit, but instead in trying to understand and make deeper tests in your code. All additional tests that you create help in the audit process by already marking code as tested. We will be having the first small space for questions. If you have any questions, please write it in the chat, and the people will be forwarding it to me so we can answer the questions. We'll be holding for like a few minutes. Okay, so no questions at the moment. You can write questions anytime you like. We will be having these small pauses a few more times during the stream, so we can go answering your questions. Let's talk a bit about what is fuzzing. This is going to be a recap because we already had a stream series about fuzzing, Learn to Fuzz Like a Pro. It was 6 parts and it's available on our YouTube channel. So you should go there and watch it to see the details about using Echidna for fuzzing. For this particular stream, you should be familiar with parts 1 and 2. That are the basics and the configuration of Echidna to run a campaign about a fuzzing campaign in your code. And next week we will be streaming about the repo, the properties repo, but with another standard ERC4626. Benjamin will be talking about properties for tokenized vaults. So back to fuzzing. The general idea of fuzzing is that you have something to test and you throw at it random inputs with the hopes of breaking it and know which inputs generate failure in the system under tests. So the first part is that we have a random input that usually shouldn't be so random because there are specific values more interesting than others. So a good fuzzer like Echidna will try to figure out which inputs are more likely to break the code than others. So it will be like trying to figure out the correct values to break it. Then we run the test, and if it fails, we save the input or stop. Now, the interesting part is that you should know beforehand what you are testing and what should be the result of your test before running a fuzzing campaign. So in this case, in this particular case for the properties repo, we know what to test because we got it from the specification, from the standards, the ERC20 standard, and we created different tests for different properties in the standard. Sorry. So what's the goal of all this? The idea is that you should be able to test the contract that, or your token, or any contract that you want to test, and see what happens with random inputs or specific inputs. If it fails, you can see that there is a bug or that your test was not correctly defined. And if you save the input, you can analyze it later and try to see where the bug was or what made it fail. There is a small detail here, is that since you are testing with random inputs, you can't assure that all the input space was tested. So there is something very important to keep in mind when you run fuzzing campaigns, is that you should check coverage and how much of your code was actually tested and how many iterations the fuzzing campaign was. to make sure that you don't get any false negative. So we will be talking about this in a minute when we go to the hands-on exercise. But the idea is that you always have to keep in mind that all your code must be tested by the fuzzer. Let's talk a bit about the Echidna. Most of you should be already aware of it, and maybe, hopefully, most of you have already used it. So Echidna is a fast, smart contract fuzzer developed by Trail of Bits. It's open source, so it's open to collaboration and users from all over the world. And it has some remarkable features that are the most interesting to mention here is that it's fast. It's actually getting faster version over version. It has support for HEVM cheat codes that we will be talking by the end of this stream. And it has color code coverage reports, so you can see in a nice colors which code was executed and which code wasn't executed. So you can check your properties or your contracts to see if why it wasn't executed and rerun the tests until you get a whole coverage in the complete contract. And of course, all the time we will have new features coming, so it's recommended that you upgrade to the latest version from our Git repo. And we will be talking now how to use Echidna to implement the fuzzing tests that we are providing in the properties repo. First of all, a general fuzzing workflow with Echidna or with any fuzzer in general is that you first have to identify your invariants or your system properties in a plain English language so you can understand what you should be testing. And once you have your system properties well identified and clearly defined, you should convert them to code. So Echidna can run that code and test the properties. These two steps are what we are providing in the properties repo. We took the time to identify the invariants for ERC20 and ERC4626 contracts, and we already converted those to code, so you don't have to do it. So once you have this code ready to test your contract, you run Echidna and hopefully find bugs, or hopefully not, depending on your implementation. The idea is that by providing this new repo, this properties repo, we took all the hard work to identify and convert the invariants to code. So you just have to run Echidna on standard contracts. If you have a standard compliant contract like a new token, you can just add the properties to your project and run Echidna and see if everything is going according to the standard. In the step number 3, you will have to configure Echidna a little bit. You will have to set some configuration parameters that we will be talking about in a minute. But for more information about this, you should be watching the previous series of streams that will have more information about this part. We'll be talking about the properties repo now, and after this we will have another pause for questions and answers. Sorry for that. The properties repo will be having a little overview here, but we will be delving into the specific files in a minute. We implemented 168 code properties, of which 25 are for ERC20 tokens, 37 for ERC4626 tokenized vaults that Benjamin will be talking about next week, and 106 properties for math libraries. We implemented them for a BDK math 64 by 64 library, but they should be able to be generalized for other math libraries. We also provide helpers that are interesting contracts that will make your life easier when you are creating your own properties. We have this interface for HEVM cheat codes that we will be talking about in a minute. And we also provide helpers to log messages during the Echidna execution, to test assertions, and to clamp integer values. So you should have a full toolbox ready for use and create your own properties for the specific contracts you are trying to test. We provide also some usage examples that we will be going through in the hands-on exercise in a few minutes. And we encourage contribution from the community. We have this contributing guidelines set in place so that you can send your PRs, your ideas, your issues, your comments to us, and we will be working on that. We'll be going to the full list of the properties. You can see that we created this table so you can easily search for specific properties and what they do and where they are located. So you can just click here and go to the property. We had these ERC20 properties, the ERC4626, and the math properties that you can go around and just check if you want. Back to this, we will be going through this specific guide of usage examples. But this is the basic documentation that we have for the repo. So everything you will need to run these tests in your project will every data you need to add this to your own project should be here. If not, just create a new issue or contact us to clarify any specific issue that you're having. And in the last link, we have some contributing guidelines, so you can write your properties for another different standard, or just if you want to expand the properties for the already existing standards, you can create your own PRs and following this directory structure and the code linting stuff, you can just send us a PR and we will review it and eventually add it to the repo. So we have this next post here for questions. There is a question that why should I use fuzzing after 0.8.0? I'm not sure if I understand this correctly, but if you are talking about the math libraries, we don't just test for overflows and underflows. We also test that the math functions actually are implemented the correct way. We test mathematical properties on the functions. So, for example, we test that the inverse of the addition is actually the subtraction, and so on. It's not just about the math overflow and underflow tests that are solved by 0.8, but we also are testing specific mathematical properties. I hope that answers your question. Is there any other question around? Okay. Remember that you can add questions whenever you want. So back to the ERC20 token. We implemented different properties and we categorized them in different sections so they are easier to implement and test your own contracts. First of all, we have the basic properties that test compliance to the standard, the ERC20 standard. Since the standard doesn't talk about new or different stuff, such as mintable tokens, increase or decrease allowance, and so on. These tests are very basic, so you will probably need more advanced tests for your tokens. And those are the additional properties that tests these features that are not part of the standard but are so common in the wild that should be tested anyway. So if you use increase and decrease allowance, you have specific properties for it. Possible tokens, mintable tokens, and burnable tokens. They have specific additional set of properties to make sure that the internal accounting is correct, and when that you mint, you actually create a new token and so on. The idea for this is some basic set of properties. This might grow over time, so we actually encourage collaboration from the community. And if you find an interesting property that's not in the repo, you should definitely add it via a pull request or by adding an issue on the repo. There are two kinds of testing that you can approach when you're testing a token or anything. The first one is internal testing, that you have access to the contract internal state, so you can read internal variables, internal state variables. You can access to internal functions. You can call the internal function from the test. But in this case, you will need to create a new test contract that inherits from the token under test. You will be like testing the token via a proxy contract that inherits from it. The other approach is external testing, and this one is testing only public and external methods, or public and external state variables. It uses Echidna multi-ABI testing that I will talk about this in a little bit. But the idea is that Echidna will not only call functions from the test contract, but also from the deployed contract, the deployed token contract. So in this test, you deploy the contract under test, your token. You deploy it as if it were deployed in a EVM chain, in a public chain, as it will be in the future. So the advantages and disadvantages of each one of these depends on what the actual token you are testing. For tokens that are simple and they have few initialization steps, or that are easy to go through the token, that are small enough, you can implement internal or external testing. It's the same. But for contracts that have more complex initialization, you should be using external testing, because the harness that you will need for deploying the token and running the tests is much smaller. The idea for external testing is that you are actually simulating what your token will look like in the public EVM chain that you will deploy it. So this has another advantage that may help you to figure out if there are some permission issues, or not, or variables or functions with not the correct visibility. So that's the idea for external tests. You interact with the token as anyone else would be this deploy. We provide harnesses for external testing, so shouldn't be an issue. You have to decide which set of tests you will be implementing. So let's go for the first example. Yeah. Okay. Can you hear me now? properties. Okay. Yeah, sorry for that. Let's go to the hands-on example and see how to implement the properties repo in your own project. What we have here is an example hard hat project for non-existent trail of bits token. We will be using this as the base token we will be running the tests on. So this is a standard hard hat example project. So I added some contracts here. We have this TOB token. It's a simple token that was created using Open Zeppelin's wizard. So it has no special feature at all. So it's a basic, simple contract. How do we go from this token to Echidna and see if it is compliant with the ERC20 standard? First of all, you should add to your project the critic properties uh, dependency. This is explained in the README Markdown file. And the instructions for doing this will depend if you are using Hardhat or if you are using Foundry. But the idea is that you have to import the properties repo to your project. If you are using Hardhat, these are the command lines that you should execute. If you are using Foundry, you should add it this way. So I already added them to the project. You can see that it's already node modules folder. So this part is already done. Now, let's create a test harness for this TOB token. We will be first using internal testing, and then we go to external testing. I've already created this in order not to waste too much time in the stream. But this harness is also in the properties repos. You can read it in the README file, and it should be somewhere in the folders in the internal parts, ERC20 internal. So the idea is to create a new contract that inherits from your token and from the properties you want to test your token with. In this case, we will only be testing it with basic properties and increase allowance properties, because it's a token that, as I said, it was created from Open Zeppelin contracts, and Open Zeppelin implements the increase and decrease allowance properties. So you will need to create this harness, and in the constructor, you will need to mint an initial balance for your users and set the initial supply to the total supply of the token. This will make our tests, the properties tests that we will be testing, will make them aware about the total supply of the token. And since this token is not mintable and not burnable, it will make sure that the total supply doesn't change over time. We'll be showing an example for a burnable token in a minute, so we will see what has to be changed in this case. But once you create this test harness, you can just start testing your contract. This is as easy as it gets. So how do we call Echidna and run the tests on this contract? We just call Echidna test. We tell it to run on the current folder. We have to make sure that TOB token is the correct folder. And we will tell it to use the contracts named critic ERC20 internal harness. And we will tell it to use the configuration file that we set in contracts Echidna config internal. This particular configuration file is also mentioned and shown in the README file, in the documentation for the ERC20 properties repo. But it's a basic Echidna config file that sets the testing mode to assertion. It uses a very small test limit. You should definitely increase this for your own project, for your own tests. We will be using 10,000 just to show it in the stream, and it's not a really useful value for big tokens or big contracts. We also say that the deployer of the contract is this address, 10,000, and the properties will be tested sending transactions from 10,000, 20,000, and 30,000. These are random addresses that Echidna uses by default. You can change it if, in your particular case, you want to make an owner contract, different owner addresses or something like that. If you want to limit the senders, you can also change it here. So we have the config file, we have the harness, and we have our token. Now let's start running the tests. If you execute this line, it will say that this is the first time we run it. We have 0 transactions saved in the corpus. So it will compile the contracts and start analyzing the properties using Echidna. This is Echidna user interface, and it is fuzzing. You can see that this is the limit that we set. And when the 10,000 iterations were completed, all the tests passed because the token is actually compliant. We have no bugs, we have no deviations from the standard, and everything works as expected. You can see that there are a lot of tests here, and all of them passed successfully. Now, what can we do at this point in the testing? We can check that all the code was correctly tested by checking the coverage. Okay. There is a coverage report that was created by Echidna when it finished the run, and it's saved in this configuration setting corpus there. We saved it in tests Echidna corpus internal. So if you go to this, you can see there is an HTML file with the coverage report. We will be watching that file and see what was covered in this Echidna run. So you will see some lines in red, you will see some lines in yellow, and some lines in green. Red lines means that the code was not executed at all. Yellow lines were executed and produced a revert, and green lines were executed correctly without any reversion. In this case, it will show all the contracts that are available in the project. And in this case, we were not testing external properties, so it makes sense that this particular file was not executed. We will be looking for the basic properties for internal tests. So the ones that, yeah. So is it possible to read it now? This is the same code that's in the repo. So if you want to read the details about this, you should go and open this file, the critic properties contract ERC20 internal basic properties, and you will see the code. The idea here is to show that all the test functions were executed, and some of them were executed correctly. Some of them caused a revert. In this case, this revert was expected because there are some requirements that need to be met before the test can actually run. So the idea is that you can check the coverage of the execution, the Echidna execution, and make sure that all the tests that you set it to run were actually run correctly. So this was a very short Echidna run, and some of the tests weren't executed. Some of them didn't meet the requirements, and they couldn't be executed correctly. So this is a useful tool to make sure that all your code is actually executed and tested by the fuzzing in Echidna. You should never mark a code file that as secure if you never actually took the time to check the coverage, check that all the code that should have been executed was actually executed. So, for example, in this case, we run short of an Echidna campaign that wasn't able to find an account that has more than 2 tokens of balance. So this transfer was never executed because the calling function, the calling address didn't have uh, more than 2 tokens. So in this case, the results of the test are not conclusive. So you can't say that the token is actually compliant and passes all the tests because uh, this test wasn't completed correctly. So the idea is that if you ever find this case in your contracts, you should increase the you should increase the test limit configuration in your Echidna configuration file to make sure that all the tests run correctly. This will obviously increase the running time for the Echidna campaign, but it will make sure that all the codes gets executed. So the idea is that we will now introduce some specific bug and try to detect it with the properties repo. There is I have already created some bug in here, modified tokens. So we will be modifying the approve function to make sure that it doesn't change the allowance of the color. So this approve function does nothing, and we will introduce it in the contract. So what we'll be expecting here is that the token is not compliant. So when you call the approve function, your allowance is not changed, and it should be detected by the fuzzing test. So this will also need a different test harness because when it inherits from the properties and the token, both will implement an approve function, and we will need to tell it which function are we referring to when we call the approve function. So I have this already prepared. So we tell the test contract to use the one from TOV token. So now we are in conditions to test this new contract with the introduced bug that should make the tests break at some point because approve does nothing. Let's run the same command again. In this case, since we didn't delete the old coverage reports and corpus files, we will start with 17 transactions that we already tested in the previous version. But when it starts running, we will see that Echidna found specific values that made the allowance tests to fail. This is a bit big. The font size is a bit big, so we will quit Echidna and see what happened. So in this text interface, it shows what happened, and it said that when it tried to set allowance twice for an account, it found this assertion failed. It says that it couldn't set the allowance via approve. So it tested to set the allowance and then checked that the allowance set is the one that was specified, and they didn't match. There is another test that failed that says that set and decrease allowance and failed to set the initial allowance. And this other set allowance test also failed because the allowance is not correct. So we made sure that the tests detected our easy to find bug. But the idea is that you can run these tests in your contract to make sure that all the the behavior that your contract has is compliant with the standard. There is another test that we will be running now for external testing, and we will be also using a different kind of token. This is an ERC20 token that's possible, burnable, and ownable. That's has an owner, but this token was also created with Open Zeppelin's wizard. So the basic function of this token is compliant. So if we run the tests, there is no major issue to be found. We have to create again the harness, but in this case, we will the harness that we will need to create is different from the previous case because we will be running an external test. So the external test harness will only deploy the token. It's like if you deployed it in an EVM compatible network. We have to tell which tests are we going to run against it, like basic properties, uh, increase allowance, decrease allowance, and in this case, the token is burnable and possible, so we add those properties as well. And that's all the initialization that we have to do. In order to tell balances, we will need to give some initial balance to some accounts, and since the harness only deploys the token, we will need to create a mock contract that inherits from our token, but not from the properties. And we set all the initial balance and all the initial configuration for the token in this mock contract. This allows us to give initial balances to different users, to set the total supply as the initial supply, and we also tell the properties contracts that the token is mintable. So you can tell the properties that the total supply will increase or decrease over time, so it's not constant. You should take a look at this. This is not complicated at all. There are some initial values that we are setting, but the idea here is that the token is deployed as a new token on a different address and independent from the tests. We will be using a different configuration file that's 90% the same, but it adds this multi-ABI setting that tells Echidna to not just call functions from the test contract, but from all the other deployed contracts in the same transaction. So when we are deploying the token and the test contracts, Echidna will call functions from both of those contracts. The rest is pretty much the same. We call Echidna instead of telling it to use the internal test harness. We will be using the external tests. Predict ERC20 external harness, and the configuration file will be different too. It will be Echidna config external. This will succeed. It should succeed at least. It's the base token, so it is compliant. There are no bugs introduced. So when it runs, it should find no issue. Again, make sure to check that the coverage is sufficient for your tests. In this case, we won't be going back to coverage because of the time constraint, but make sure that every time you use Echidna on a contract, make sure that the coverage is complete, or at least as complete as possible. So we will be also introducing a bug in this contract to make sure that the properties are detecting the issue. And again, I already have the the bug created here, so we will be copying and pasting the bug into the contract. In this case, the bug will be that the burn function, this token should be burnable. The burn function, instead of burning tokens, will mint new tokens. It will mess with the internal accounting, so it should be detected by the properties repo. Again, in this case, we will not need to modify the harness because it will just deploy the token as it is. We don't, we will not have any collision from two different functions from different contracts. So we just run the test again the same way we ran it before. And if we are lucky, Echidna will detect that the burn function is not according to the standard. It was really quick. So it tests the external property for burn, and it says that it expected to be all nines, but it was too bigger than expected. That's because it didn't burn, but instead it minted one new token. And the reason was that the source balance was incorrect after burn. So it tested that the burn function removed tokens from the total supply, but instead the implementation for the burn function created new tokens. So that was detected by the test. The idea of this, of course, is to run the tests as thoroughly as possible, increase the amount of iterations, the test limits here, and if it doesn't find anything, you should try a bit longer, a longer campaign, and so on. But these properties implemented here should help you find the most easy to find the low hanging fruit from your implementations. So let's go back a minute to the not that one, this one, to the slides. What are the takeaways that we can mention from this part of the stream, this first part of the stream? We were able to identify and write properties for your contracts. We show you how to do it. We also showed how to test contracts with Echidna once you have the properties written. And we used fuzzing test as a complement to static test. We actually added additional tests for free into your project to make sure that the token is compliant with the standard. So from a developer point of view, all the effort was already made, and you just only run the fuzzing test with Echidna against your project. This should be used also as a learning exercise on how to identify and how to test the contracts and create new properties for other standards. If you are working with contracts implementing other standards, you should also do something similar to what we did here with ERC20 or ERC4626, so you can make sure that your contract is compliant to the standard. So now we will be talking a bit about the bonus part that were introduced in Echidna latest version, the cheat codes for HEVM. So what are the cheat codes? Most of people that already used Foundry are familiar with this concept. Cheat codes are a way of manipulating the execution environment, so you can achieve results that are not normally achieved in a running live EVM. So you do this manipulation by interacting with a contract that lives in a specific address and has special methods such as, for example, prank to manipulate the message sender for the next call, sign to create message signatures given a private key. You can manipulate contract storage for any contract that is deployed in that virtual machine by using load or store. And there are a few others. We will be checking the list in a minute. But the interesting point here is that this is meant to be used with care, because abusing cheat codes is an easy way of having false positive or false negatives results in your tests. You can do stuff that you would normally not be able to do in a live environment, such as, for example, starting transactions from contracts, initiating calls to external functions from a contract. That's not allowed in a live EVM. Or you can change for example, the block timestamp or the block number in the future or so. So if you use cheat codes in your tests, make sure that you understand what the implications are and what the risks you are taking by using these cheat codes. So let's quickly see the full list of cheat codes that are implemented. You can change the block timestamp, the block number, the storage, read and write storage in arbitrary contracts. You can sign messages or transactions. You can get the public address from a secret key. You can execute commands in the system shell, so you can communicate with processes running outside HEVM. And finally, prank. We will be showing how to use these cheat codes with a hands-on example, but we won't be running the examples to make it a little bit shorter. But the idea is that you have to import this helper that we are providing, that we call HEVM.sol. And but in this contract, you will see that there is a specific address. We will be opening it. So you can see there are the interface for all the functions that we mentioned, and there is this constant address. That's where the HEVM cheat codes did. So by using this helper, you can do stuff like this. For example, change the current block, change the current block timestamp, and you can run, for example, tests for time logs or for stuff that depends on the current block number or the current block timestamp. And you can perform external calls by pranking the message sender. You can change who is the message sender of this call by using this cheat code. Again, this should be used with care, but it helps you to create more advanced tests. For example, in the case of ERC20 tokens, that usually you need to be given allowance to use the tokens from a random account. You can just use prank and call approve, and that makes the tests easier to do and to call Echidna on those tests. Make sure you understand the risks and use them with care. So I think it's time for the last part of okay, that wasn't the window. Sorry for that. this was the window. We will be hosting a new stream about the rest of the properties in the properties repo next week. Benjamin will be talking about ERC4626 and the helper functions that were not mentioned in this stream. We want to thank you very much for joining our stream and using our tools. And we can pass a bit here to see if there are more questions in the chat. Not sure. No. Okay, it seems that there are no questions visible. So thank you very much, everyone, again. Please subscribe to our YouTube channel, to our Twitch channel, and see you all next week with Benjamin and ERC4626 tokenized vaults. Thank you very much.